Hello, everyone, and thank you for joining our Payment Page Security with PCI DSS version 4 webinar today, sponsored by ControlCase and Jscrambler. My name is Chad Leedy, and I am the head of strategic accounts here at ControlCase. My background is I've been in the PCI world, the assessor world for about 15, 16 years. And I'm excited today. We have a great topic to discuss that I think is going to be very interesting. I want to walk through our agenda and some housekeeping items. So we do have several presentations for you today. The first one is going to be on mitigating e-skimming threats and data leakage with Pedro Fortuna. And then John Elliott is going to talk through preparing for PCI DSS 4.0, the payment page requirements. We're going to have a short break, and then we're going to have a panel discussion on PCI readiness with the whole panel. And then we're going to have a credit card services and Jscrambler demo, and then have a live Q&A. So talking about the webinar as a whole and just some housekeeping items. We will have a Q&A session at the end of the webinar, and you are welcome to submit your questions. We will try to get to as many questions as we can. If we are unable to answer your question, we will try to answer them via email to follow up. There will also be a recorded session of this webinar that we will distribute afterwards. So if you have missed part of it or unable to attend the whole webinar, this will be available. So with that said, we will go ahead and get started. Our first speaker is Pedro Fortuna. And a little bit about Pedro. He is the co-founder and CTO of Jscrambler. So Pedro leads the company's security research and product innovation for the company. He has more than 15 years of experience in researching and working with web security. His main research interests are in the areas of application and web security, reverse engineering, and software engineering. He's a creator of solutions that require code rewriting, sandboxing, or both. He's also the author of several patents in application security and a regular speaker in international security conferences all over the world. So with that, Pedro, I will hand it over to you.
Thank you, Chad. So let me share my screen. Hopefully you can see it. All right, good to go. So, so Chad already presented me pretty much. Again, I'm CTO and co-founder of Jscrambler. I'm also a board of advisor at PCI DSS. And throughout my career, I've been working in application security for the most part. And in recent years, I have given several talks at several security conferences. So for today, I'm going to talk about e-skimming, and let's first define what is e-skimming. E-skimming is basically the digital equivalent of credit card skimming. So in credit card skimming, you have a physical device, usually installed over an ATM to skim the credit card information. So it's similar to that, but it occurs digitally, usually in code running inside the browser when a website is taking payments. And this is done by one script that it's either malicious to begin with or has been compromised and suddenly starts skimming credit card information as it's typed by users of that website performing payments. So let's see it in more detail. How do they work? So it starts by you embed a script that loads JavaScript, potentially from or usually from a third-party server, and that code can load additional code without your consent. We call that fourth-party code. And third-party code is also very commonly loaded through iframes. So iframes load HTML, and from that, it loads additional JavaScripts. So a typical website will have dozens of third-party scripts like this. Many of the organizations publishing these third-party scripts are very small and do not necessarily have good security practices. So that means that they sometimes can very easily be compromised and through that start injecting an e-skimming on your website. By the way, e-skimming is also referred to as online skimming or mage carts or even form jacking. It is important to become familiarized with the several ways that people often refer to this type of attacks. But from a PCI DSS perspective, we call it just e-skimming attacks. Now, like I said, imagine all it takes is one of these scripts to become compromised, and it kind of infects the whole execution environment. And this is true for every user session. So in every user session, all at once, there is one script just collecting and massively leaking that information out the page. And this is usually done in a silent manner. Another way to do it, after they have been able to collect that information, usually they exfiltrate this information to an attacker-controlled server, usually to an unsuspecting domain name like Coolest Fonts. So it's hard to spot. It's not visible unless you're looking at the code of the page, and it happens in a massive scale to all your users. By the way, the server to where the information is exfiltrated to is called a drop server. If for some reason Coolest Fonts is not allowed, for instance, if the website is running some sort of allow list of domains, they accept loading or sending information to, which you might know it's possible to do using, for instance, content security policy, then another way to do that is just by leveraging a domain that it's actually accepted as per that allow list. For instance, they can send information to the server that has been compromised. The attackers probably have a foothold on that server as they manage to change the JavaScript. They could also be in control of that server. They can just exfiltrate the data to that server and from there to any other domain. And another way to do it, which we have seen countless times, is to pick one of the other allowed domains like Google Analytics, which like 99% of the websites will use Google Analytics. They just create an account, their own account in Google Analytics, and they just exfiltrate the data to the Google Analytics account, which actually works as just a receiving end of any type of data. And once the data hits that Google Analytics account, they can just grab that information and put it somewhere else. And so you may ask, how is this even possible? It seems like far too easy. Well, the problem originated almost 30 years ago when the same origin policy was defined. This is still the fundamental security isolation brick in every user web application, in web applications and in any browser-based code. And it basically states that for two JavaScript execution contexts, one can only access the DOM, so that's basically the structure that holds the structure of the page and any information being entered into the page. One script can only access the DOM of another script from a different origin if they have the same origin. So they have to share the same origin. If they are from different origins, which we call cross-origin, then this access is quote unquote restricted. But restricted how if we can do this? So we can roll out a page, an HTML page, and we can embed a script loaded directly from a third-party server. And that code, once it loads, it benefits from the same level of privileges as any other scripts running on the page, even the ones from like the first-party scripts or the page's origin. So in reality, and this is a very technical and somewhat subtle thing that even developers themselves often do not fully understand how the same origin policy works. In reality, as per the same origin policy, a third-party script embedded is allowed. What is restricted is directly writing to or reading from a cross-origin. Now, let me pause here and just do a comment on embedding. So this embedding is actually very convenient for facilitating code reuse, pushing new features fast. We just, we embed code from different parties for quickly assembling our application to get started quickly. And this has actually made web technologies the preferred method for developing and delivering software to people. If it was any other way, it would hurt speed of development. So you have a trade-off here. But however, it was terrible for security. So that means that we have to live in a world where third-party scripts are able to, without our knowledge necessarily, they can harvest any user inputs from the interface, from forms, without the application owner's knowledge or even the user's knowledge and consent. They can pull more scripts, like fourth-party scripts. They can hook into browser events like mouse clicks and keyboard typings. They can change what they do and what they will cause. They can actually fully modify the behavior of the web page. So when they go that far, we say that they are compromising the integrity of the website, of the page, because the page is not displaying what the programmer intended. Maybe the user is seeing like a wrong, like some phishing message to trick the user into doing something against their interests. The user can be scammed, and it's also able to intercept like network information being sent out, so it can do a sort of a man in the middle if they want from inside the browser. And these are just a few examples. So you may ask, well, is there any way to design around this, like to avoid creating this situation? Actually, there is. We can. There is a somewhat old method that involves moving every third-party script that we don't fully trust to inside a cross-origin iframe, and then implement a protocol to post message back and forth data from the parent window into the iframe and back. So if the script gets infected, because it's isolated from the parent window, because it's inside the cross-origin iframe, it cannot directly access the parent page's DOM. It cannot collect payment information. And in fact, it becomes restricted to what the implemented communication protocol will allow it to do. Now, if we have more than one script, we have to do this again and again. So we have to isolate that new script into a different iframe. So we are also isolating scripts between themselves, not just between themselves and the parent page. The problem with this approach is that, in fact, third-party scripts often presume access to the page information directly to the DOM. You can, like, imagine scripts or vendor services like Google Analytics running only inside an iframe, what kind of information will it be able to collect? Really, almost nothing, because they're missing out on everything that it's taking place throughout the application. So therefore, it wouldn't work. If we want it to work, we would have to pass this information to inside the iframe where Google Analytics is running, and Google Analytics would have to be changed or adjusted to allow receiving information that way. So we kind of have to extend Google Analytics, and we have to do this adaptation and protocol and maintaining and changing and updating every script to work in this way, which, like, it's a lot of work, and it's probably the reason why a lot of people are not using this method, and it kind of failed, although it's still like anyone that wants to follow this approach, they can, but it will eat out some of the benefits of using web technologies. So what else can we do to defend against e-skimming attacks? We can do one or multiple of the following. So I'll just go through each of these four and explain in more details. So you can limit the amount of scripts included. If you don't include scripts that you don't really need, they will not, even if they are compromised, they cannot hurt you. So you have to be mindful that not only these scripts can be compromised, but if they are included, they can bring additional code. And sometimes the problem is with the additional code. So when we include a script, we're trusting the ability of these organizations to ensure the integrity of their scripts and the scripts that they are including. Secondly, you have to limit the scripts that can be loaded into your website. This sounds a little bit similar to the previous one, but it's different. So the previous one, you are not actively including scripts in your page, but if something compromises the website in any way, they can basically add any script they want to the page. This one, you are actively telling the browser, hey, these are the scripts that I allow that could be loaded on my website. Now, they could not be loaded, but if they are, the browser will take it. And any other script not named will basically be refused by the browser. So you can use content security policy for this. It's a security header. So you just set a list of domains. You can also specify file hashes, wildcard domains, and those assets will be accepted. The file hashes are actually similar to another thing that we can use, which is sub-resource integrity, which we'll talk about more later. CSP is also criticized for having some limitations. For example, it's not granular enough. Once a script is accepted, it can do whatever it wants. So in that sense, it's not good for fighting e-skimming, because the danger usually comes from scripts that our website actually needs and that we have already accepted from the get-go. Unless you can use CSP to protect against new scripts that could be loaded for some reason, like could be pulled from the scripts that you already accepted, those will be blocked. But the problem is, if the skimmer activity comes from a file that you already accepted, then CSP will not do anything to prevent it. It's also easy to break the application because it's difficult to keep up with all the files that you accept. in your application. So if a developer happens to add a script to your application and someone misses updating the CSP policy, then you might break your website, you might break payments, and that is a big no-no. It's generally like difficult to maintain, especially if it's big websites. You don't believe me? Then look at this. This is Walmart's CSP policy. Imagine the work of the guy who suspects that 1 or 2 new domains are missing from this list. Just checking that list seems like tiring already. So in our view, CSP is not good in this regard. It feels like a bouncer at the door of a venue that either accepts the file or not, but once that file is in, once that script is running, then it can do whatever it wants. CSP is not the only way to limit the scripts that you allow running on your website, but it's probably the number one example that people know. So we talked about SRI before. This is where we come back, and John will, I believe, might also touch upon SRI in his presentation. The problem with using file integrity or file hashes is that it can only, in practice, it can only be used by first-party scripts because you control them. You know when you are changing them. So you can update the hash of the file, but it doesn't really work with third-party scripts because they tend to change without your knowledge. They can change at any time. And if you use SRI to control whether the script can be loaded, then there is even one thing that it's worse is that SRI, when that script changes for legitimate reasons, SRI will prevent the browser from loading that script. And it does that without sending any notification. So it's a silent block of that file. And you only find about it because your users start complaining that things are broken. And again, that's a big no-no. Another way to do this is by making these scripts tamper resistant. So this mechanism involves rewriting the code, which usually is done during the build process. And because you only control the builds of your part of the application, not of the third-party scripts, in that way it could feel a little bit similar to sub-resource integrity because you cannot tamper protect third-party scripts. However, this is good practice and it's recommended by several security standards and legislation. And we should, generally speaking, ask or require or even require third-party providers to use tamper-resistant technology and to apply this type of measure. During the execution of the code, if any other script tries to interfere with the code-resistant script, the script will react defensively. And the good code protection will also protect against monkey patching, which is a particular type of interference with scripts that allows malicious code to rewrite what other scripts functions do. So it's basically changing your code by changing what a function does, one function at a time. So that has to be included in what the tamper protection is applying to the code. Lastly, even when we accept a script to run on our page, we should limit its access and permissions following the least privilege principle. It's a measure of isolation and security. And to do this, we can use sandboxing inside the browser. Now, how it works, it will depend a lot on the solution that you use. Of course, in this case, I'm mostly thinking about Jscrambler's product, Web Page Integrity. And so I'll use that as a reference here. So in our case, it works like a transparent layer that observes the behaviors of each script at the very moment they are about to happen. And using a pre-configured set of rules, we can either allow or block these behaviors. And we can also just alert. So our rules are very expressive, they're granular, so it's possible to specify with great precision what we intend to allow or block, unlike CSP, which basically just fully allows a script or fully denies that script. So when some behaviors are blocked, but not all of them, so we still let the script do some things, we call this behavior attenuation. And as I said, this strategy follows the principle of least privilege, which means that in the future, if the script is compromised, it still cannot go beyond the behaviors that it was already doing previously. And in this way, the problem is mitigated. So we're just containing the blast radius of the problem because not fully allowing the script to do whatever they want. So from a script perspective, if we attenuate the behavior of a script, like I said, we allow that script to run, but we disable certain specific behaviors, and we call this script fencing. So this is like a shorter way to refer to this attenuation. So we say that we fence the scripts into attenuated behavior. Another feature that and functionality that it's extremely effective in mitigating e-skimming is called form fencing. It consists of specifying which scripts needs to process a form. Typically, this is just one script, well-known, hardly changes, that it's used to do the client-side form validation before the data is submitted to the server. And by limiting that form access to that script only, we automatically and forcefully exclude all other files from accessing that form. And so that doesn't mean that means that you don't have to, recognize new scripts that might potentially want to access your forms and roll out a rule to say that particular script cannot access the form. You don't have to do that. You only have to point out, this is the one script that I allow to access that form. I couldn't do a presentation like this without actually showing you what an e-skimmer looks like. And I specifically picked the Inventa breach that targeted Ticketmaster some years ago. So when you reverse engineer the code that you saw, this code, you kind of understand the typical steps that a skimmer takes in order to skim the data. So first it checks, am I running on the right page? They usually check for the presence of some words on the URL like checkout. Then they iterate all form fields and known IDs. They install listeners to clicks on those fields. They collect all form field values when they run, and basically when someone is submitting the form, or every X amount of seconds, it collects the data and sends this data to a drop server. So it's pretty straightforward, and it might run again after some time. So obviously, this problem needs to be addressed. But you might ask, can I just delegate the problem away? So some years ago, in order to not be in scope for PCI DSS, you would just ask a payment service provider to get you an iframe form payment form. Is there any other thing like that you can use to delegate the problem away? Well, in the context of PCI DSS, you now can't. So it used to be that case in the previous version in 3.2.1. But now you can't. So there are two new anti-e-skimming requirements that were introduced, 643 and 1161, that not only they apply to the payment page inside the iframe, which belongs to the payment service provider, but it needs to also be applied to the parent page, so the page that is hosting the payment iframe. And the reason for that is that we now are fully aware of a number of attacks that can affect the parent page that will result in the leakage of the payment data, even though that payment data is being entered inside the cross-origin iframe from the payment service provider. And I'll give you a couple of examples. The first one is iframe overlay. It's pretty simple. In this attack, a compromised script running on the page will create a second iframe and will place it exactly over the real iframe, therefore deceiving the user. The second example, compromised scripts will basically monkey patch, will replace the set attribute function of the browser, and such as when the legitimate script, the payment service provider script, is creating the payment iframe, when they call the set attribute function, they will be calling a modified version of the set attributes that will check if this function is being called to set the source attribute of the iframe, and if it is, it will replace whatever has been passed to this function by the malicious script where the iframe should now be loaded from. So this is called iframe hijacking. We had more examples, but to be conscious of time, we'll advance to the conclusions. So the whole problem of skimming or data leakage on the client side in general was originated from the way we build applications. Applications are inherently vulnerable to their supply chains. A compromised script can change what the page does, what the user sees, and can capture all information, including payment information. So this is a problem of integrity. And solutions like our web page integrity that limits what a script can see and what they can do are usually very effective way of addressing the problem. So sometimes I ask people, what is the worst thing they can imagine from a security point of view that could happen to their assets and applications? I often get as response that well, probably a breach to their server that ends up like just leaking the entire database. Obviously, like you could be thinking that way too. It's easy to understand. But what it's not so easy to understand, but what I want to convey here is that a data leakage on the client side can actually be as bad as leaking the database from the server. Because all information passes through the client side before reaching the server, and payment data is introduced in the browser before being transferred to the server. And what's worse is that on the client side, the payment data is not yet encrypted, while on the server, if they have done their job, the data is encrypted, like the payment data is encrypted, and is useless for the attacker actually, while on the client side, it's still in clear text. And even worse than that is that these scripts can actually steal the information while it's being typed into forms. So imagine a solution, you're typing something and, you know, like, and sometimes like the browser starts like filling those forms for you, like, and it's you start like deleting all of that. You have time to delete it before like sending it to the server. But if the skimmer is just polling those forms, it's just like capturing that information before you finish typing, before you finish submitting, then even more sensitive data can be stolen and exfiltrated. So from an effort perspective, it's generally easier to and cheaper to compromise the client side than to compromise the server. All they need to find is a third party with weak security practices and compromise the script's integrity. And that's all I had for you. Thank you. I look forward for your questions if you have any.
Thank you very much, Pedro. Really great information that you shared with us. Appreciate it. All right, we are going to move on to John Elliott, who is a security advisor for Jscrambler. Just a little bit about John. So John is an expert in regulated security and data protection. He has represented Visa Europe and MasterCard on the PCI Security Council, has contributed to many of the PCI standards, including most recently PCI DSS version 4. And he just recently took on the role of security consultant at Jscrambler. So I'll turn it over to you, John, for preparing for the new PCI DSS version 4 payment page requirements.
Cool, thanks, Chad. I think you've already quite nicely introduced me, so I'm going to be really quite brief about that. But yeah, as Chad says, I've been in PCI now for about 16 years. I was both MasterCard's and Visa's reps to the PCI Council. I've implemented as well, so I've been a merchant. I was at EasyJet and took the airline through PCI DSS. Well, a long time ago, I was a QSA, but don't hold that against me. So I want to follow on from Pedro's presentation and really talk about what the problem is. As Pedro has demonstrated quite nicely, that any piece of JavaScript running on the page can do anything to the page. So that's the technical problem we have at the moment. And that practically the entire internet now is built by assembling JavaScript in real time in people's browsers. The vulnerability we have is that the attack surface, of course, is all first and third party scripts. If I want to get my malicious JavaScript code, my skimming code, the thing I need to do is to get it into some other JavaScript that's already been loaded in the page. And I thought very, very beautifully that Frank made a great comment that, like, if you're using CSP, then that tells you what JavaScript's been loaded in the page. F12 tells you what JavaScript's been loaded in the page as well. The dev tools tell it. So the attack surface is any piece of JavaScript that's loaded in the page, whether that's from your site as the merchant or from any of the third parties. And the threat is, this is how most cardholder data is being stolen now. Because we've got EMV widely rolled out in Europe and the States and the rest of the world, most cardholder data theft is from e-commerce environments, and a skimmer is by far the easiest and the least detectable way of doing it. And so when we say that the skimmer needs to just go onto one of like two third-party, onto the skimmer needs to get put into some JavaScript that's already been loaded in the page, you might think, well, that's not going to be a big deal, John, is it? But the problem is now that the amount of JavaScript that people use has absolutely ballooned. We did a survey a couple of years ago, actually, no, last year. We looked at a lot of the top e-commerce websites in the US. On average, they had about 100 different JavaScripts on them. About half came from the first party, about half came from third parties. One of the reasons there is so much script, and especially so much third-party script, is because of something called a tag manager. Now, if you've not met a tag manager, let me give you this is like a 1 minute sidebar digression into tag managers. Tag managers is a little piece of code another piece of JavaScript that's put on the site. The idea of a tag manager is that, the digital and marketing teams want to add JavaScript to the web page to do tracking, to do A/B testing, to do advertising, to do remarketing, to be able to sell your data, frankly, to tracking companies and profiling companies. And to do that, of course, they have to go to the web team or the development team says, can you add this bit of JavaScript? And can you add this bit of JavaScript? So a number of companies, predominantly Google and Adobe, worked out that what we want is if they give a little bit of JavaScript that's called a tag manager, then they can provide a web interface to marketing and digital so that they can add JavaScript to the website without bothering the development team. And so Adobe says nice things like, oh, it allows developers to do other important work and allows marketeers to gather, organize, and manage website data. And I think a tag manager is a system that has been explicitly designed to get information security and change control out of the way so that the marketing and digital departments can put random JavaScript from somebody that no one's ever met on an organization's website. So that's what a tag manager is. So given that a lot of cardholder data is being taken this way, and given that a new version of PCI DSS came out a couple of years ago, what was in the PCISSC's thoughts about how to reduce the risk? And the answer was they added 2 new requirements. The first requirement is 6.4.3. And if you're familiar with PCI DSS, I'm using the slightly updated version of 4.0.1 version of the standard. 4.0.1 came out, I think, probably about a month ago. And so in 6.4.3, it says basically that things need to be authorized, that needs to be inventory, there needs to be justification of why it's necessary, and unity of integrity. I like to think of it as there's really 4 legs to 6.4.3. And this is a much clearer way of seeing the standard. So the first is you're required to have an inventory of all JavaScript that's running on the payment page, or in the case of an iPhone, the parent page. So you need to record when it was added, when it changed, when it was removed, and your assessor will probably want to see it, so you probably need to retain that information for a year. The second thing is it needs to be authorized. And in terms of what information you'd need to retain who authorized it and when they authorized it. The standard doesn't say who has to have authorized it. The implication in the guidance column is that it's by management, but it could be by anyone. And it has to happen, it can happen either before the script is added to the page or after the script has been added to the page and it was detected. Because sometimes, like marketing will add a script to the page that no one knows anything about, but when you detect it appears, then you can authorize it or not authorize it. And you also need to record why it's on the payment page. In 4.0, it said necessary for a payment. Now there just needs to be a business or technical justification of why the script needs to be on the payment page. And so you might look at these 3 requirements and say, hang on, John, this is just busy work. This is just compliance tick box nonsense. And the answer is, yeah, but this is compliance. This is filling out spreadsheets and getting people to justify things. And if you're thinking, gosh, what a lot of compliance nonsense it is, you're right. The reason that we put this in the standard like that is to encourage people not to want to do that, so that they will say, gosh, that's a lot of compliance nonsense. Let's understand how much JavaScript's on the payment page, and I can reduce it so I don't have to do all that compliance nonsense. As we'll discover later, that's probably not happening, but that was why the compliance requirements were written in the standard that way, to make people focus on the attack surface and then reduce the amount of JavaScript that was in the attack surface. Because a lot of breaches happened where people had no idea that code was on the payment page, or even more worse, like the supplier of that had no idea why it was on the payment page. And the next thing is that in 6.4.3 that the integrity needs to be validated. Now, integrity isn't defined in PCI DSS, so we use a standard definition of it's effectively safe and not being tampered with. So the script does what it says it does, it's not malicious, and it hasn't been tampered with. And in guidance, it says you can use content security policy and sub-resource integrity, as Pedro's just talked about, or you can use proprietary script or tag management systems, which can prevent malicious script execution, a bit like Jscrambler's products. So that's 6.4.3. That's the first requirement. If you think of the NIST cybersecurity framework, that's a govern, identify, and protect type of requirement. The other requirement is 11.6.1, which is a detect requirement. So it says we want a change in tamper detection mechanism to find unauthorized modifications to security impacting HTTP headers and the script contents of payment pages, and you need to check at least every 7 days. So again, I like to think of that as 4 different blocks, and let's look at these individually. So first of all, you want to check for changes in JavaScript that could compromise the payment transaction. So any JavaScript that's already been authorized, has it changed? Has it become malicious? And it needs to be reauthorized. Secondly, there's a number of security HTTP headers, most importantly CSP. And the idea is that you need to monitor changes to CSP, because if I am an attacker and you are using CSP and I want to get my JavaScript loaded from a different third party, I need to be able to edit the CSP. It can also remove protection as well. So you need to monitor the fact your CSP hasn't had an unauthorized change. The standard didn't want to specify how you should meet it. It was very clear that when we were developing it, as I say, I was on the committee, the working group that developed the standard. We didn't want to tie it to a particular product or technology solution. So for this, we said, it has to happen at least every 7 days. I mean, ideally, you do it in real time. And if you want to do it even more than 7 days, you could do a targeted risk assessment. But that targeted risk assessment might also say, actually, if you're doing a really high volumes of transactions, you need to monitor for changes in a lower frequency than 7 days, maybe every day. And then finally, when there is a change of an unauthorized change, when there's an authorized change detected, you need to alert the entity. So it doesn't say the consumer, there's a JavaScript that changed. It's the merchant or the service provider needs to be notified. And then they need to respond to that alert in the way that requirement 12.10.5 says. So those are the two requirements. Those are the two new requirements. And they apply to the payment page, which... and I'll tell you a bit of inside baseball here. I think it took us a month to come up with this definition of a payment page. So anyway, it's a web-based user interface containing one or more form elements intended to capture account data in a single document or instance, in a document or component displayed in an inline frame, an iframe, within a non-payment page, or multiple iframes within a payment page. So that's what a payment page is. It's the blue bit, which if you know PCI DSS, you'll recognize that if you're doing the single document or instance, that's an SAQ AEP or SAQD or a full ROC. Whereas if you're using an iframe, that's an SAQA, where the payment fields are in one iframe or in multiple iframes. However, because of the attacks against the iframes that Pedro showed you earlier, it also affects the parent page. It's written in probably some of the worst language I've ever seen the PCI SSC write. You have to really unpick this to say it also applies to scripts in the web page that includes the processor's payment page form in an iframe. Okay, so it applies to the merchant's parent page. For the merchant, it doesn't apply to the PSP scripts. The PSP scripts are their responsibility. That's what it says. I could have written that much quicker. And so as a picture, basically, the PSP and the merchant both have to comply with this requirement. The PSP for the scripts in their iframe or iframes, the merchant for the scripts in their parent page. So the question is, how do you implement it? And if you read the requirement, if you read 6.4.3, it sort of leads you to a workflow that looks a bit like this, that someone in the business says, I'd like to add some JavaScript to a page. And then they document the necessity of it. They send it off to InfoSec, who say, is that JavaScript going to be malicious? Is it going to be authorized? And if it's not, then no, you can't have it. And if it is, then we record detail of the approval. We add it to the inventory, and then it gets added to the page. It sort of implies that type of workflow. And then if the script changes, the person says, I'd like to change some script in that JavaScript. So again, document the necessity. Yeah, if the JavaScript, if it's just adding a comment, you probably don't need to redocument the necessity. Otherwise, if the behavior or the functionality has changed, you probably need to document the functionality. So you document it, and then, I'm sorry, PowerPoint can't do the nice little square arrows properly. Check it's not malicious, and if so, then it's authorized, and if not, then it gets taken off. Otherwise, we record detail of the approval, update the inventory. Yeah, we should probably update the inventory. There's been a change in the script, and we don't need to add the script to the page because the script's already on the page, so we're just doing a document. So that's sort of what you would think if you read 6.4.3 about some type of workflow in your organization to manage JavaScript. But what we found in the past 2.5 years of doing this is that all companies or all entities or all organizations are very different. If I give you 3 examples, like the first entity's maybe just got 25 first-party scripts, They're all managed by the development team. They've got a really good CI/CD pipeline. So they could probably do this like pre-change authorization, and there's one third-party script from their payment processor. Whereas Entity B's using maybe Node.js or something in a framework, they're really good at change control in the framework, but they have 35 third and fourth party scripts that marketing and digital are adding via a tag manager. Whoops, and I pressed the wrong button then, as you saw. And then Entity C's got like 200 first party scripts. They're all dynamically generated by website code, and maybe hundreds of third and fourth party scripts. And Entity C is not uncommon for large e-commerce websites now. And so what I want you to concentrate on is the words of the standard, because the standard says, right, that you need to confirm that each script is authorized, and you also need to have a method that's going to alert personnel to unauthorized modification. So what I really suggest you focus on when you're thinking about how to implement this in your organization is to focus on that authorization stage, because everything else comes from that. The inventory, the justification, necessity, right, focuses on the authorization. So 6.4.3 new scripts need to be authorized. 11.6.1, you need to have an alert on unauthorized changes. The standard does not say unauthorized. In fact, I'm going to delete this. The standard does not say unauthorized scripts must be blocked. I've heard some QSA say that it very clearly and very deliberately doesn't say that. We didn't write it like that because it's actually really hard to block unauthorized scripts. There's a couple of products that do it. Jscrambler is one of them. But again, you do not want to write a requirement in a security standard that only one or two vendors can fulfill, that doesn't give enough of the market for people to be able to choose the way they implement something. So what we found basically is that you tend to need multiple authorization processes for new first-party scripts and then for changes to first-party scripts, for new third and fourth party scripts, and then changes to third and fourth party scripts. And those authorization processes are going to look like one of these three things. The first is you probably want a policy that says, by default, you will authorize low or zero risk changes. And by default, I mean they're blanket authorized. So if in a first party, if someone adds a comment or something like that, you don't want to go through this authorization workflow. The reason being is that, like, you see maybe 50, you might see 50 changes a day. That's going to give you alert fatigue, and you're not going to catch the one alert that you need to. So in some cases, you'd be able to pre-authorize. So before a page is changed, you will be able to run that organization that has a really good CI/CD pipeline with good change control. They'll be able to have tickets to change the JavaScript, so first-party JavaScript. That's pretty easy. But in many cases, you will need to post-authorize a change when you have noticed the change. 11.6.1 makes you notice the change. Now you need to post-authorize. Is that a valid change? The reason being is that marketing and digital are going to be adding things to your website, and then when those things change, like when, for instance, if you've got Google Tag Manager on your page or Google Maps or something like that, just imagine any random piece of JavaScript from a third party you're liable to have on your payment page, and then that third party wants to change it. They're not going to ring you up. They're not going to ring you up and say, "Oh, hello, it's Google. Do you mind if we change Google Maps JavaScript? Can we have your approval?" So, like, you're not going to be able to authorize it. So you end up with these three different types of authorizations. You default authorize low-risk first and third-party changes. You pre-authorize new first-party scripts if you've got the maturity to it, and then you post-authorize everything else. And if you're saying, "Oh, can we do post-authorization?" Yes. In version 4.0.1, it really clarified in the guidance column for 6.4.3 that the authorization, where it's impractical for authorization to occur before a script is changed or a new script added to the page, the authorization should be confirmed as soon as possible after the change is made, which means you end up needing a workflow that looks like this instead. It's that a new script is detected, typically by IT operations, and then InfoSec want to check it's not malicious. And of course, if it is malicious, it needs to get removed from the page pretty quickly. If it's not malicious, we ask the business, why is that script necessary to be on the page? They'll tell us. We then say, is that going to be authorized? I've put that authorization in InfoSec. It could equally be in the business. It could be it just needs to be somewhere. If it's not authorized, it gets removed from the page. If it is authorized, then we need to record details of the approval and update the inventory. So that will be the workflow for a new script, which means you then need to look at having the capabilities to do all of the things there in that nice pinky magenta color. And then for a change script, again, You need the capability to detect a change. Again, that comes to InfoSec, check if it's not malicious. If it's not malicious, or if it is malicious, remove it from the page. If it's not malicious, work out if the behavior or functionality has changed. Because if it hasn't, we can just update the inventory. But if it has, we need to redocument the necessity, then say, is that authorized again? And if not, remove it from the page. And if so, again, record the detail of the approval and edit the inventory. And again, that means you need these capabilities in a tool or whatever. Now, I'm nearly at the end of the presentation. I want to go to what I think is probably one of the two most important slides, which is this. You need to do some documentation first before you work out how you're going to manage this in your organization. You need to work out what your current process for adding new JavaScript to the site is. Who can do it, right? And then what's the process for changing JavaScript? And is there any automation to use any dynamic scripts? And believe me, it will not be the same for first and third party. And you will need to often think about this, as I said before, in three different ways of what's the process for new first party scripts? What's the process for changes to first party scripts? What's the process for changes for new third party scripts? And then finally, what's the process for changes to third party scripts? Do the business analysis first before you actually think about how you're going to do it technically. This is the most important thing. We've seen people go off and decide to do it technically one way and then work out that that won't fit in their organization. So what are the four options you've got to do this? There are basically, there are four possible solutions you have. A redirection, you could use CSP and SRI, you can use external monitors, or you can use agent-based solutions. I'm going to go through them very quickly. So, if you redirect to a payment service provider, you're on the checkout page, you hit Pay Now, and then rather than staying on the merchant's page with the payment form in an iframe, you wander off to a payment service provider. So now the consumer is having the conversation with the payment service provider. 643.1161 are not applicable. That's the easiest thing to do. But then you lose control of the payment flow, and you lose control of the look and feel, and it might confuse the customer if they're now on somebody else's website to make a payment. The second thing is, as Pedro showed, you can use content security policy, which is set in the HTTP header, and that's where you can load JavaScript from. And then you couple that with sub-resource integrity, which you add a hash for every piece of JavaScript that's going to load. And then when the browser loads the JavaScript, it also makes the hash and it compares the two hashes. If the hashes don't match, the JavaScript doesn't load. Here's the problem. SRI fails silently. It doesn't give you an alert. It doesn't send an alert back to you like CSP does, say there's been a violation of SRI. It just doesn't load the JavaScript, which will break the page quite frequently. The other problem is that many bits of third-party JavaScript change a few times during the course of a day, and you can't keep up with updating SRI. So CSP and SRI will work if you only have first-party JavaScript on your web page, and you have a really mature CI/CD pipeline, which is 100% automated, so that as you push a change to the JavaScript, you can push a change to the SRI at the same time. If you can't use CSP and SRI, you'll need a tool. And there are two sorts of tools that are in the market, mostly for people to do something. The first are external monitors. So you can think of this as a synthetic user or a robot, effectively. They go to the payment page, they analyze it, they look at all the third-party scripts and the first-party scripts, they make an inventory, they can kick off an authorization process. Because they're inventorying, they can see there are changes when new scripts appear or existing scripts are changed, and then they can send you an alert. You often have to train them to navigate to the payment page. Sometimes you have to put stuff in your basket before you can do a checkout. Sometimes you need to log in before you can do a checkout. So often they fail because the thing that you're putting in your basket runs out of stock, or somebody changes the payment flow and forgets to tell the person who's running the external monitor. So they're not perfect, but they're jolly good. You can scan at least every 7 days. More frequently is better, especially if they have a skimmer, the more cardholder data you'd lose if you didn't notice it. So frequency should be related to transaction volume. And Jscrambler has a product that does this. It's called our agentless web page integrity. The other thing is an agent. And an agent's also what Pedro showed you earlier about sandboxing JavaScript. Jscrambler have a product that does this, as do a number of other companies. And so you load the agent first onto the page, and then it monkey patches the browser and watches and manages what any other JavaScript does. Jeff is going to give you an example of show you how it works in a minute. The great thing is then that the agent can send telemetry back to you, so you can see there's any problems. You can see when changes happen. You can kick off authorization workflows if anything changes. The great thing is you detect changes in real time because it's loaded into every consumer browser, so you don't have any of the problems associated with scanners, and it can block malicious behavior. Some of these agents can actually see that a skimmer's on the page and actually block it stealing the cardholder data. And as I said, an example of that is Jscrambler's web page integrity. Here is the second most important slide. Don't choose a tool until you've done that process mapping and understood how your organization currently manages scripts and wants to manage JavaScript. So that's the second most important slide. What can you do today? If you ask, ControlCase, working together, we can give you an inventory of the JavaScript on your website today, so you can use that to start planning how you're going to meet these requirements. The first thing I've always done is go, well, that's interesting. Who added all this JavaScript to the site? So you have to go around the organization. So if you ask Chad, or if you ask any representative you have with ControlCase, that can happen in the next 24 hours. You can get an inventory of the JavaScript on your site and start to take control and manage it. And so I'm going to hand back to Chad now. Chad, over to you.
Great. Thanks very much, John. Really important information. So we are going to take a quick break, around a 5-minute break, and then come back with our panel and also demo and some more important information. So we will be back in 5 minutes. Thank you. All right, everyone. We are back from our break. Thank you for spending time with us so far. I think we've had a lot of really great information shared from the Jscrambler team. So we are going to now invite our other panelists back and start our panel discussion. So give everyone a couple minutes to jump back on. Hey, John.
Hey, how's it going?
Going great. Great presentation.
Thank you.
All right, and there is Pedro. All right, so the way this is going to work for our audience is we have a few topics that we are going to talk through, and then just like I mentioned in the beginning, we are going to have a Q&A session at the end. So we've got your questions. Thank you for participating. We did receive your questions, and we can also add to those questions if there's anything in the panel discussion that you're interested in us following up on. So with that, it's going to be sort of a free forum panel discussion. And so I just want to start in terms of the main challenges organizations face when trying to achieve and maintain PCI DSS compliance. I mean, it's a pretty big topic, and obviously we've seen a lot in our various roles. And so I just want to kind of talk through that and get everyone's perspective. I don't know if one of you wants to kick that off. Maybe John, if you want to kick that one off.
Yeah, I mean, for me, I think the answer is, and it sounds really dull, is to view compliance as a continuous operation, not as a point in time. Obviously, when we start getting compliant, we run a gap analysis, and we often kick off a project to get ourselves compliant with the requirements. And then we sort of let it go a bit. And so my experience is and the standard's very good about this. The standard says you need to keep up with, there are some requirements that have got a fixed thing in, like network security reviews every 6 months, vulnerability scans every 3 months. So So there is some stuff in the standard, but when I'm managing PCI DSS, in fact, and it's what we do at Jscrambler because we're a service provider as well, is that we have a spreadsheet that says, here are all the things we're going to do to check that all the controls or the requirements we expect to be in place are in place, and that we don't discover that they're not in place the month before we do our assessment and we do a new gap assessment. So a focus on continuous compliance is the thing that I would highly recommend. And the thing that I look at, Chad, is, if you remember, there's something called the prioritized approach for PCI DSS. Which is great when you're getting compliant, because it says do these requirements first and these second and then these third, because these are the one that makes the most bang for the buck in terms of security. And what I do is look at the prioritized approach and say, okay, the ones that give the best value for security, I want to check that those requirements are in place maybe once a month. I'm just going to go and do a quick sample. I'm just going to go and talk to the person in network security and check that this has happened. I'm going to go, and I'm doing this from the top of my head, so this might not be the same as in the prioritized approach, but I'm going to go to the system and check, for example, that everyone who's left has their account deactivated. So I'm going to pick some controls and say, let me just check these on a regular basis, rather than wait until the QSA does it for me at the end of the year. And then compliance happens all the time, and there's no shock at the end of the year. And your QSA will love you, which is really important because of being nice to QSAs and making them love us.
Yeah, great point. I mean, I couldn't agree with you more. I think a lot of times there's this tendency to sort of look at it as a checkbox and just do things in a very sort of reactive way, or not very proactive or not fluid. So great point. Pedro, I'll give you a shot.
Yeah, I just want to underline something that John said, that you really have to prepare this as something that will be continuous. So you basically can look at it as in two parts. Like the first part is you need to get compliant first, and then you need to keep to maintain compliance, right? And a metaphor I sometimes use, and I apologize if anyone gets offended, hopefully not, but is basically like you're on a diet, right? And you cannot just like use any method on a diet. You have to use a method that you will be able to keep up with after you get like your desired weight, whatever that is, you know. So when thinking about compliance, is you don't just think about how do I become compliant. You have to think about what methods for compliance will I use that I will be able to keep doing afterwards. Otherwise, like 2 months down the line, and you are out of compliance again, and it will not work. So you have to really like think about the method, the organizational processes, and things that will just not work once, but will keep working after that.
Yeah, I mean, it's a great point. And I think, when you talk about method, Pedro, I think one of the things that I've seen in working with, especially in the retail and restaurant space, is just the limited number of resources that these IT teams have. And so it's great to have these grand plans and methodology. It's another thing to have the resources to pull it off. And when those resources also have to have some objectivity. So a lot of times people struggle with the ability to do the work that they have to do every day of the week, but also play an objective party in looking and being part of their PCI program. And one of the things that I recommend to people is that not to try to do it alone, to really utilize partners to help you here. And I think, a really great QSA and really the methodology we look at is that your QSA should be your partner. Your QSA should not just be an auditor that comes in. They do have that role, but they also should help you prepare for the future. So your assessment may be over, but then immediately you're preparing for that next assessment and walking through the technology changes that you're inevitably going to have, right? So I think that's part of how you deal with the resource challenges that everybody faces. And you can't be an expert in everything. And there's so much technology that's being thrown at us with AI and just there's just so much that it becomes overwhelming unless you have a partner in each area. So utilize your MSPs, utilize your service providers, utilize your QSA. Make sure that get them together. Get your partners together and help create an augmented team because you can't do it alone.
That's even what we do at Jscrambler. We actually hire our QSA to come in every couple of weeks and do that control checking throughout the course of the year. Because we might not be objective if we're running the controls ourselves. We might not have the resource. So it's not actually our assessor. It's somebody else in the team. And I think it's one of their junior QSAs or one of their associate QSAs who comes in and they do that. Right, here's the spreadsheet. We're going to check these controls this week. And I'm sure that's the service that you offer at ControlCase as well to your clients.
Yeah, that's really just part. We call it an engagement, not just an assessment, right? It's an engagement. But and just moving on. I mean, I think this next question kind of pushes us that direction. So what are the essential steps to prepare an organization for PCI DSS 4.0, and obviously we moved even beyond just 4.0 for April 2025. And I'll just start with telling you kind of our approach to it. We've looked at how we want to prepare our clients, and what we've done is we've sort of taken a hybrid approach where we have consolidated the 3.2.1, the older with the newer, so that we can sort of baby step into it. So you're not just, charging hard at 4.0, but we're sort of helping our clients evolve to it. And we've been doing that. We actually started that a while back so that it wasn't such a shock to comply with the new requirements. But with that's kind of our approach with everything, is just to partner with our clients and make sure that they are prepared well before they have to make a wholesale change. And so that was something unique that we did, is we created a hybrid consolidated approach to make sure that our customers were aware, and we were educating them the whole time to say, hey, this may not be required today, but this is going to be a best practice for the next version to prepare. So, John, any feedback on your side on preparing for 4.0?
That's one piece. I know that some people haven't quite got to do 4.0 yet because their next assessment's not due, and Ian will answer your question next. But the one thing I urge people to do is there are 64 brand new requirements in PCI DSS version 4. And one thing I'd say is a really good time to look at your scope, because is your scope correct? Or should this help you, incentivize you descoping? Every requirement costs money to implement. Every requirement costs money to manage, and it's an ongoing cost. So if you look at some of the things in version 4 and say, actually, that's going to cost us a fair amount to implement. We have to keep it running, and it's going to increase our cost base of either a technical control or what people have to do. Could we do some descoping so that requirement affects fewer system components, people, and processes in our organization? So I would use the opportunity of a change in the standard to say, is our scope right, or could we descope more?
Great point. Pedro, any feedback from you?
So I don't think I can add as much as if I focus on the implementation of the 643 and 1161. When thinking about those two requirements, these are one of the many future dated requirements that will come into effect next year by the end of March. And my advice is really understand the trade-offs and the caveats of like the different ways to meet the requirements. John, as he mentioned, he was heavily involved in writing these two requirements, and obviously they were, as any other requirement on the PCI DSS, is designed not to be dependent on on vendors, on commercial solutions. They are specifically designed to be met with free and open source or any technology that is readily available. But you have to understand that that doesn't make those approaches necessarily the free ones, quote unquote, because in as any engineering or business leader knows, that a lot of things might not cost anything to acquire, but they might cost like a lot to maintain. And these are the trade-offs that you really need to understand. Like if you want to do maintain an inventory, you can maintain an inventory with pen and paper if you want. Like you just have to at least every 7 days to have someone looking at the page and see if you have new scripts, and then you have to make sure that you trigger a process for someone at the company to look at the scripts, understand what changed, understand if they are not introducing any new risks, and authorize those scripts and provide like a justification. You can do that, all of that, with pen and paper if you want. But the thing is, as we know, and strike that, maybe not everybody knows that the typical third-party scripts might change like every day, several times. If for some reason your risk assessment tells you that you have to check for changes every day or even every hour, because every 7 days introduces a risk that you might not be willing to to accept, that you might have a skimmer for 7 days exfiltrating payments, that might not work for your organization. So you might want to reduce that and do it more often. And then you have to realize, but how often these scripts will actually change? Well, they might change every 5 minutes, and they will not tell you. So really think about the trade-offs and decisions that you're making. Because something is free at the beginning doesn't mean that it will be free in general. You might need to hire people to do that. You might not have the people at the moment that will be able to do that. You have to pay for their training. You have to work out the processes. You have to make sure that those processes are in place and that they are working. You are not deviating from those processes. And if you take all of that into consideration, maybe some turnkey solutions out there might end up being cheaper and will reduce the overall risk of not meeting the compliance and passing the assessment, because they just work. They just take away the problem for you, and they use a lot of automation so that your team is not buried in authorizations and justifications that you have to do every day.
Oh, great stuff, Pedro. So how can organizations balance meeting PCI requirements with their business needs and their strategic objectives? John, do you want to give your input on that?
We've got quite a lot of questions in chat, Chad, and questions. Are we at a time where we could answer those now? So I want to make sure we do them before we run out of time.
Absolutely. So I know that Frank had a couple of good questions. Actually, he had several. So I know the first one was for iframe form. Are most other requirements NA other than 6.4.3 or 11.6.1? Do you want to take a stab at that one?
Yeah, you bet. So for the iframe form, you need to follow SAQA. SAQA has got. I'm doing this right off the top of my head, and I could put it on screen. I could put it on screen, but I'm not going to. You can get it from the council's website. So I think there's probably 20 requirements in SAQA. So it's a very much cut down number of requirements. It's things like the big thing is you need to have a vulnerability scan every quarter now. That's a new change in version 4, and it's things like having policies, having passwords, doing the vendor management in 12.8 basically. So Frank, yeah, most of the other requirements are NA, but there are some that are applicable. And Laurie, what's the current recommendation for current iframe users is, yeah, you have to meet these 2 new requirements. And so the recommendations are exactly what we have talked about today, which is you need to work out who's adding scripts to that parent page. One recommendation I would actually make that will make it much easier for you is to make sure that you can create 2 separate domains in your tag manager, and you can have one for the whole site, another one for the payment page, or you can actually put the payment page on a separate domain and make it a completely separate site. So that will make it a lot quicker and easier for you to do this. And then, Frank, you ask another question. That's 2 questions, Frank. I don't know if there's any allowed. It's definitely in scope, and it is a really good question. And the answer is some new FAQs from the PCIDSS completely answer those questions. They just released some new questions about that because it's actually not a simple answer. So I am going to link you to... if I copy, let me just copy a link address and see if, oh man, see if I can't use technology now. So I'm going to put in 3 links in the chats, in the main chat to PCI FAQs that came out perhaps in the last week or so.
This is not phishing, right?
No, it's not phishing. It's actually proper ones on the thing. Frank, you found a hard time finding it because literally these FAQs are probably 2 weeks old. I just linked to the same one twice, then, didn't I? Let me actually, rather than do this, Frank. Rather than give you a fish, let me show you how to fish. So that's all the FAQs on the PCIDSS website. There's brilliant stuff there. And you want 1570, and you want 1578, 1579, and 1580 answers your questions. Yeah, the FAQs is actually not much better. It used to be terrible. Your next question, Frank, is a consulting question. I can't answer that in a general webinar because I'm going to do the QSA answer of it depends. JB, brilliant question. Does PCI DSS 4 or 4.01, we haven't got 4.1 yet, cover strategy on how to achieve compliance if using zero trust? Yes, it does. There's in fact, John put in a great thing. A new information supplement came out literally on last Monday that talks about this. The other thing is we added the customized approach, which was particularly designed for people using zero trust. In other words, you're not going to meet the defined requirements in the standard, but you are going to meet the security objective or the control objective or the requirement objective. So you can use the customized approach where you use zero trust to meet a lot of PCI DSS requirements. And there is a question in questions, isn't there? There question, which is from Ian. Oh, so Ian has a brilliant question. Go on, Chad.
Well, I was just going to say, Ian, a great question. But since we sort of have a methodology for navigating this, I think probably want to get with your specific assessor at ControlCase and how we're handling this for you. So definitely I'll touch base with you after this and make sure that we answer that per how we're approaching your specific assessment. But it's a great question.
It is. And I guess one of the things I forgot to say is DSS4 became effective on the 1st of April this year. The new requirements that require anything and the 2 we spent a lot of time talking about, become effective on the 1st of April 2025. But how you transition to that, as Chad says, good discussion with your assessor. Does authorized.net provide? I have no idea. If any other PSPs provide built-in e-skimming detection or prevention mechanisms. They should. They can do. They definitely can do that, and I think they should. And I think, but you should ask them to do that. You should ask them to help you with that, because they can certainly do that.
John, if I may jump in,
sure.
One thing that our research team is finding is that many of these PSP iframe implementations are actually not perfect. So we were able to, identify a number of different attacks to the iframe, to the payment form iframe implementation, where we could either, in all of these attacks, we could compromise the data. We could grab the data. But in some of them, we could grab the data without even disrupting the payment flow, while making the iframe, the initial iframe, same origin. So we broke the cross-origin protection of the iframe by using certain methods. Now, if the implementation, if the security, the hardening of the iframe implemented by PSPs is perfect, they won't allow that. So there is a way. So this is the good news. There is a way to prevent them. But what we're seeing out there is that a lot of PSPs out there don't have a flawless hardened implementation of the iframed payment form. And so, I do realize it doesn't answer your question, but it just hints to the possibility of not only they don't have specific, or they might not have specific e-skimming detection, but their iframe implementation, their segmentation is not perfect either. So, which means that they have a bigger problem, bigger fish to fry before they consider directly mitigating e-skimming. They should first make sure that their iframe implementation is flawless.
Thank you, Pedro. All right, we are going to move on, conclude our panel discussion and move on. Please continue to send questions as you have them, and we will try to get to them in our Q&A. So next, I want to introduce Jeffrey Cleveland, who is a sales engineer at Jscrambler. He is going to show us Jscrambler demo, and then we are going to walk into our control case overview, give a little information on control case. So just a quick intro on Jeffrey. He has been with Jscrambler for 6 years and has helped organizations understand the client-side risk, identify compliance obligation, and he does serve as an industry advisory board member for the College of Cybersecurity at Anderson University in South Carolina. So, Jeffrey, welcome, and we'll turn the floor over to you for a demo.
There we are. Great. Thanks, Chad. Yeah, let me get started here. And what I want to show first is I certainly want to jump into the product and show the dashboard, but I want to show a little bit about how we work, because I think it's a bit unique in the space for these types of solutions, and certainly among others. So let me start here, just a single slide for you. And this here is just going to show the hybrid deployment model for our web page integrity solution, where we actually deploy in a number of different ways. Of course, we've been largely talking about this agent deployment here that's at the bottom. This is the section that is most relevant for what I'm going to show as far as the feature set, but you should know that we have other methods of deploying that are both quicker, but also serve to back up that original agent deployment. So just kind of starting down here, the agent itself comes from code that's embedded into the payment page. So you add a single line tag, the same types of tags that Pedro discussed in his presentation. That single line tag will connect to will cause the user's browser to connect over to our services, pick up a copy of the agent relevant for your payment page, and allow that agent code to load. Once it does so, it'll be able to both monitor and configure the page in case there is a need for the agent to intervene and to configure or effectively block certain features of different scripts. This is great because we're talking about real user sessions. It's continuous monitoring, so it's anytime someone visits the payment page, you're not having to worry about those intervals, times, things of that nature. And it covers both detection and blocking. Of course, blocking not being part of the standard, John covered that, but a feature that we do offer as part of our PCI offering. Other things unique, these WPI services back here that will collect all the information from the agent are wholly owned by us here at Jscrambler, as well as some of our other providers. John mentioned these are all assessed environments where we can then drive out notifications over to the admin team, send information to the dashboard, and analyze information from there. That's what I want to show here. There's an agentless monitoring component. This is great for kind of getting started very quickly, getting some information into the dashboard, and in some cases we'll use this to check, then make sure that the data we're getting from the agent is correct, that it's loading accurately. But from here, I want to jump to the dashboard. So web page integrity is a larger product than what we're going to talk about today. Web page integrity, as the name implies, is capable of managing really the entire website and protecting sensitive data, the function of the site, and some other types of risks that can be introduced by JavaScript. Of course, today we're talking about PCI DSS, and so I'll take you through that module that we've built specifically for these requirements. And as well, you can just use this module. There's no need to have the entire feature set in order to meet these two requirements. So here I'm going to start within the payment page manager, and this is where we're going to largely be mapped to 643. If you'll remember from John's presentation, the components of having an idea of the inventory, of authorizing that inventory, recording the justification, and having some way of starting to track the behavior of those particular scripts. So in here, or track the integrity. In here, I've got a few different scripts that are already authorized to be in the page. And rather than scripts, we instead look at vendor services. So take Facebook Pixel or Google Tag Manager, for example. These particular vendor services are, as the name implied, made up of both the vendor and then the service that they're providing. These could contain, I believe in this case, I've just got one script, but could contain many. This allows you to approve, authorize, and review scripts in groups rather than one by. It makes it a little bit more practical in terms of bringing that information back to something that is more familiar, rather than showing you, hey, here's a single line of code, or here's a single script. That's here's what this vendor is here to do on the page, and here's what they're actually doing. And so you'll see that I've got this little authorized button in a lot of these, but I've got two that are not. One is Stripe, and here, the reason this one's showing and needs review is highlighted over in the history tab, where we're saying, hey, this has just been detected today, and so is now showing as a new script. Now, the background here is that we're swapping to Stripe for payment processing today, and that's why they've shown as a brand new script. Authorize them, right? This is our kind of post-detection method where we can then take a look at the behavior of the script. We're given kind of a summary, but we can go through and take a look and see, hey, what are they actually wanting to do on the page? Well, they want to add an iframe to the page, and it gives us the source domain, stripe.com. When the card information appears in a form, it is being accessed by the script or group of scripts, and then they want to do a network transfer to stripe.com. All of this makes plenty of sense, right? Stripe exists as a payment service provider. You would expect their script to do things that could get their hands on the card information, and so we can go through and authorize this particular vendor to reflect We can give a short description. Hey, in this case, they are the payment processor, and then decide whether we want to allow everything that they're doing in the page or customize those authorizations. In this case, I'll allow everything. And when I do that, this will start to build out what we call in the background behavior contract. This behavior contract describes, hey, here's what Stripe is allowed to do. And as long as they stick to that, there won't be a need for Stripe to go back through the reapproval flow. That's where we're going to fall in that default authorize process. So if Stripe changes their code, but doesn't change the way that they interact with the cardholder, they're still sending it to the same places, if they're still collecting it from the same places, then we won't change that behavior. This makes it a lot easier for the merchant because now we're only having to check on scripts when they do things that could affect the security of that cardholder data, which is what I have here with full story. This is an example of where they were previously authorized. We'll keep that audit history over here, where you can see a John F. went through here and provided the initial approval of full story, but now it's changed now a week and some later, and we can see what has changed. That's highlighted for us over here in the behaviors view, where we can see that now they're adding an iframe where they weren't previously. It's quite suspicious. They want to access not just the email address, which is what they're accessing before, but now all 4 of the card fields. And they want to transfer that information to a number of different domains, but maybe one that we don't trust so much, if you kind of pardon my blatant naming scheme there. So what can we do? Right. Well, when we go back through to reauthorize the vendor, rather than simply allowing everything that they want to do, we can go through and customize this and block any, and in this case, let's do all features of full story. And when we save that, this will update the rule set that the agent that's being distributed out to the cardholders, to the people checking out on the website. This will allow it to understand that, hey, the next time I see full story, I'm going to prevent it from interacting with the card data in these ways that we've just described. Now, this is more of doing it in a post method, but what we set up for most of our clients is actually doing this in a kind of proactive protection method, where we go in and determine, hey, how exactly is card data going to flow through the site? Is it just going to be in the iframe? Is it going to be in a form on your page? And go ahead and protect those things in advance. And then rather than blocking, as I've done here, allowing when a new script shows up. But we can set up anywhere in between those two, just dependent on what works for your organization. And so very briefly, what I want to show is that even though we're blocking some information, I'm going to go through kind of a quick checkout here on our Jscrambler shoe store. Even though we're blocking a lot of information, blocking a lot of features from full story, it's a very elegant block that prevents full story from having access to the card data for sure, but also allows the user to go through the normal checkout flow to enter their card data, and for us, the agent, to be able to confirm that, yes, I did protect this card data as it went through, the session did occur, and they did not lose their data to that skimmer. So in a lot of situations, even with a skimmer in the page, the agent will be able to confirm that it's able to protect a user from these types of attacks. And of course, we'll generate alerts on all of this and deliver that over to a SIM, and can be there to help you to understand what's going on if you do get to the worst possible state. HTTP headers are something that 1161 also asks you to monitor, and we do this by baselining and generating alerts that deviate from that baseline. They're quite simple to enact. Simply looking at a header type, you may decide that something is or is not a value that is accessible for or acceptable for your page. When reviewing those headers, you either authorize to add them to the baseline or discard in order to remove it from or not add it to the baseline. Any headers that have been authorized will then not generate an alert if we observe that header again. So moving back over to my alerts pane here, which really pulls all of them together. We'll give you a summary of any alerts or any approvals that you should do in order to remain compliant with the solution, in order to kind of follow this defined approach here. There are other ways that we can kind of get towards the customized approach or the compensating controls that are available in a couple different assessment types. But in this case, I'll kind of leave this as a teaser. And certainly, if you have other questions, want to see other features, or maybe you think that web page integrity, there's some other areas that might help you managing other types of sensitive data that your organization handles, certainly get in contact here with ControlCase, and we can provide a full demo, kind of talk about how this would work exactly for your organization, and start really nailing down what it would look like if you were to put it in place. Chad, and back to you.
Great. Thanks so much, Jeffrey. Great demo and great information. All right. Well, I want to tell you a little bit about ControlCase before we wrap up with our Q&A. But by the way, thank you so much, everyone, for participating today and asking such great questions. And I know there's some discussion going on in the chat right now, so keep that up. That's great. So ControlCase is well, from a PCI perspective, is a QSA. We're a global company, and we were founded in 2004. Our headquarters is in Fairfax, Virginia. We have QSAs globally. So not just a global company, but we do have a QSA resources all over the world. And I think that from a go-to-market perspective and how we choose to operate is really important. We are a company that has huge clients, names that you would know that could go to any company and have their assessments done. But we also pride ourselves on being sort of a boutique company that works really well with smaller organizations, and especially organizations that maybe are new to PCI or have just gotten themselves in a position where they become a service provider, or they something has changed in their environment. So I think we can, we're big enough that you can be confident that we can scale with you, and we can work with very large organizations, but we also want to partner with small organizations as well. And I'll go a little bit more into how we do that. But this just kind of gives you a snapshot of who we are and kind of our credibility and credentials. But the way that we do this, I think, is pretty unique. We look at ourselves, I think I mentioned this earlier, as having engagements, not just assessments. And so we look at our partnership approach combined with our technology as creating the most efficient way to do business. So the goal is, and I know this may seem counterintuitive, is we want things to get easier for you. Obviously, once you have gone through an assessment, especially if this is your first time or you are assessing in a newer environment, we want to make it easier for you in the coming years. So the idea is that we want to create an environment where technology can create efficiencies, and our Compliance Hub portal. I know everybody loves to talk about their portals and thinks their portals are great. We don't utilize our portal as a nice to have. It's really the center point for our engagements. So there is an AI component built into our portal where when you upload evidence, that evidence is almost instant. There is a review process that happens, and then that is combined with a human element. So it makes it easy to do things in tandem and have an iterative approach when you're using AI and technology. But the idea is to take all of those tasks that can be done through technology to make it more efficient and also bring costs down. And I know that we talked about resources. It's very important to utilize resources in the most efficient way. And on our side as well, when we deploy a team to help you and an assessor, we obviously want to maximize the use of our assessor's time. So we're in the same boat. There's only so many resources, and we want to utilize technology to make it easier, more efficient, and more cost effective. We also have continuous compliance services. What we mean by that is we do have services like pen testing and ASV scanning. I will say we are not a managed service provider. So I know that there are a lot of assessors out there that wear multiple hats, or their companies sell other services. We really focus on security standards and assessing. So there's really no conflict of interest there. And also one thing that is unique about us is that we are able to assess multiple frameworks at once. And I know that other companies are talking about doing that now. We were really a pioneer in that space. So we've got a very mature methodology. So if you are needing to assess for SOC or for ISO or HIPAA, high trust, we can help you do that in tandem with PCI. And Compliance Hub, our portal, will automatically pre-populate the NIST and those other security frameworks, even if you're not buying those assessments from us. As a courtesy, we're showing you the overlap there. So again, it's all about being efficient and making sure that these security standards are easily accessible for you. And we call that our one audit methodology, and it's assess once, comply to many. But again, if there are several audits that you are having to undertake in a year, then we'd love to talk to you about how we can make that much more efficient. Uploading evidence is one great example. Combining evidence and having it be relevant to multiple security frameworks is something we can do within the Compliance Hub portal, so that you're not doing more work than you need to do. So with that, if there are any other questions, I think that there are. I'd like to bring in the panel again to answer some of these questions. It looks like there are a couple of questions here. John, Pedro. So Mohammed asks, what could be the minimum turnover of a business to consider to make services feasible and make an ROI? John, you want to take that one, or?
I'm technical. I literally know nothing about anything related to conversations like that. I just do technical stuff. That's one for Pedro.
Gotcha.
Yeah, I would like to say the same thing because I'm the CTO, but I do understand. However, the question is complicated because it depends what you gain by being compliant with the PCI. I mean, if being PCI DSS compliant is what puts you in business, and the only way for you to get profits, then the ROI on being compliant might be very high, and the costs of acquiring a solution like Jscrambler might be pretty much affordable in that sense. If on the other hand you are hardly selling anything, I mean the ROI might be complicated. So it's difficult to answer that question.
Well, let me try to make this easier. Let me try to make this easier because I think it kind of ties into N's question. Do you want to kind of talk through how pricing is structured at a very high level in terms of Jscrambler?
Yeah, absolutely. So for web page integrity, we have several modules. If you are just aiming to become PCI DSS compliant, and you want to address those two requirements, the 643 and 1161, then all you really need is the PCI DSS module that we offer. You don't need the whole platform. We do more than like having an inventory and providing support for authorizations and review the behavior of scripts that are changing. We have more than that. We provide an overall way to prevent scripts from just collecting data from your website, like personal data, sensitive data like patient health information, social security numbers, etc. So you can shield your own overall your application from that. You can also attenuate the behaviors across your website. So you want to watch out what scripts are able to, like create cookies on your website, might be tracking your users, or to just like change the UI in a way that could deceive your users. If you are interested in a broader scope, then obviously the whole platform is more expensive. But the context here is PCI DSS, and that module is priced on a per payment page. So the more payment pages you have, the more you pay. Usually we can simplify, and every brand website might have a single payment page, but that's not necessarily true because depending on the region, you might have multiple payment pages, and then you have to monitor them all in order to be compliant. So the more payment pages you have, the more you will pay per year. So that's essentially how it works. But because we're not acquiring the whole platform, it's less expensive than the whole platform. There's also two options on the table. Unlike every other vendor in this space, we say that we have a hybrid offering. That means, what we mean with that is that we have an agent-based approach, so where we'll give you a script, you have to embed that script on your payment pages. That's the one we have for years. And we also have an agentless offering. I think John touched upon this in his presentation. That agentless, we don't give you a script. We just create synthetic sessions. We go to the website, we do a payment flow, and then we can do inventory. You can check for scripts that changed. This offering is less expensive, but we didn't develop as a cheaper option. That was not why we did it. We did it because we want to offer our customers the flexibility of, for instance, start with the agentless, start with something that will not require any integration, and then when they're ready, they can move to the agent implementation. So that's just a convenience to many companies. And we do have customers that have weird scenarios where they control some of the brands, but other brands they don't control exactly, because like they have grown through acquisitions and they don't know what is the team that controls a particular website, but they still need to cover all of those brands and payment pages, so they can have a mix of agent and agentless to cover all of those. Overall, it is true that the agentless is cheaper and easier to get started with.
Great, thank you, Pedro. And we can certainly make sure that we provide you specific pricing for your needs, so we can get in contact with you to provide a proposal for the tool. So I think we have time for probably one more question before we wrap up, and it looks like we had one from earlier. What measures and tools should be in place to ensure the integrity and security of the payment page and JavaScript files? Do one of you guys want to take that one, and then we'll close out?
Maybe you, John, can answer this one.
Yeah, I think I covered. I hope I covered a lot of it in my presentation. So basically, look, the simplest is by using content security policy and cyber resource integrity. But again, that might be, and again, if you miss that bit of the presentation that's being recorded, you'll get a link so you can rewatch it afterwards. So I'm going to try and condense half an hour into a minute. So content security policy and sub-resource integrity will certainly protect the integrity of the payment page of the JavaScript files. The second thing you can do is then use a tool that we've been talking about, like Jscrambler's web page integrity or some sort of scanner. In terms of other methods, you need to look at where the pages. We have to think about this in terms of first-party scripts and third-party scripts. In terms of first-party scripts, it's all the controls around PCI DSS to protect the web server where it's coming from. So, file integrity monitoring if you're pulling JavaScript from files, access rights control. I mean, the whole gamut of the PCI DSS controls are designed to stop an attacker getting at your scripts. However, I'm going to be really honest. By far the largest number of attacks are from third-party scripts, not from having first-party scripts attacks. For larger merchants and for smaller merchants, like level 4 merchants, the majority are scripts, are people attacking scripts that are first-party scripts. And let me tell you how they do that. They attack web servers that are not patched. So if you're using Magento or WordPress or any of those packages that give you a website, but you're not up to date on your patching, that's how the majority of those websites are being compromised. So I guess the biggest advice, the biggest measure that will help you keep secure is to make sure that you patch your website, and not just the operating system, but more crucially, the framework that's running the website. If that's Magento, then upgrade to the latest version of Magento.
Thank you, John. And that question may have come in before your presentation. So
that's what I guessed, which is why we have a recording, so you can catch up on it.
Absolutely. Okay, before we wrap up, I think that there is a really important question that I want to pass over to Pedro before we wrap up, and I'll read it out since it was in the question area. Since this whole concept of attack is to inject code to alter execution of the page, what protection do you have to prevent an attacker from disabling Jscrambler?
Yeah, really good question. We have a number of ways of addressing this. I will share a few. So, for instance, for one, if something is able to block our script from loading or from working properly, but let's consider the simpler case. It's blocking us entirely. So we would see a drop in the number of times that we're monitoring the page. So that would be number one, then the obvious. And you wanna check these types of interference because when in a typical e-skimming attack, that's what happens. They will massively run in every payment page of every user and start collecting data. If they don't want Jscrambler to be running over there, and if they manage to block us, then we would see that drop. It would be a massive drop in terms of monitoring. Then we have other mechanisms like positive acknowledgements that we run and we're not interfered with, that we remotely attested that everything is fine, and we have ways to, once the script is loaded and starts doing things that might potentially interfere with our agent, it has to be able to break the sandbox in order to prevent us, or at least to instruct their browser to do so. So we are not so worried in one person somewhere blocking our script once. That's not super impactful. And another one which is really good, we have our agentless infrastructure checking the page every once in a while, and that put us in the position of owning the browser. And we have more privileges, so we can secure and make sure, and we have observability, so we can check if a script is trying to do that from a perspective of running the browser. So we have extensions, we have lots of different things that we can do, and we do them to attest that nothing like that has happened.
Great. Thank you, Pedro. Great question. Thank you so much for everyone that has participated and joined us today. Just want to remind everyone that if you would like to reach out to us, we are going to be sending email follow-ups with the recording of the presentation, and we're happy to jump on a call and answer any questions that we weren't able to get to today. But I want to thank the Jscrambler team for a great webinar, and we look forward to talking with you guys in the future. Have a great day. Thank you very much.